go ahead and open up a new Colab notebook. That is colab.research.google.com and click on that new notebook link. Okay, we're going to use the MNIST dataset, but we're going to do it looking at traditional machine learning algorithms. Let's call it MNIST. It's called ML for now. Distinguish it from ML stands for machine learning, distinct from DL, which would be deep learning. So where is that data set? It is in here in this folder. It's different places. It's all over the internet. It's actually one of the most famous data sets ever. You'll see what it is in a moment. So if you look here, there's a training and a test set. It says small because there's a larger data set. We're actually going to make it smaller so that it doesn't take too long. Okay, it's a large data set of handwritten digits. So what I want you to do is open up these two. Well, I want you to open up this CSV file and take a look at the data. Let me do it with you. So you want to copy the path, okay? And then let's just call it data equals inside of quotes. Copy that path in there. Let's go and do the test one as well. So copy that path. And let's call that data test. That way we go ahead and get the test set right out there right away. Okay, now we want to go ahead and use pandas to load in the data. So import pandas as PD. And then to read in the file, we want df equals pd.read underscore CSV. These are CSV files, data. And then let's do df test equals pd.read underscore CSV data test. Okay. And then what I want to do now is simply look at just the regular data frame. I think it's safe to say that the data test will match it. So let's look at DFA. Let's see what we got here. What are we going to see? We're going to see a bunch of numbers. Well, you can see what it is. It's strangely numbered at the top, and it's like a lot of zeros. So this may be a little confusing, but we're going to piece it together. I do want to make a correction here. So let's put header equals none on both of these. I think the columns aren't labeled. So when header equals none, they're just going to go to indices. And I did forget, I do want to shorten the rows of both of these. So you can do that using in rows. It can go anywhere, actually, it can go at the end. So in row stands for number of rows. I like to, well, what can I say? I like to put it before header. So how many rows are we going to do? Let's do 2,000 in the data frame, okay? If you want to see, well, how many are there originally in this smaller one, you put in df shape, okay? 20,000. And we could totally do it. It's just, I've run code before, and I don't want us to just be sitting here waiting for code to run during class time, okay? 2,000 is sufficient, I think, to get the job done. And then similarly, we want to reduce the test set as well. So the test set is usually about 10% of the training set. We could go a little higher, maybe like 250. Okay. There's no right or wrong answer here. Normally, when you're building like a final model, you actually want to test on all the data, but it's not uncommon to experiment on subsets of the data so you can get your code right. Okay. So let's do it again. Make those changes. Go ahead and run this cell. And you can see it's now indexed. Okay. And if we check the shape now, I can rerun this cell. You can see it's got the 2,000 rows and 785 columns. So, as I mentioned, these are handwritten digits. They don't look like handwritten digits, but we can certainly show the handwritten digits, but we have to reshape it. So this data set is set up actually in a machine learning friendly way as individual pixels, okay? There are ones in there, they're just hard to find because, oh, look, there's a 15. So, that's like some type of a color code, like the RGB thing. I don't know, like, images that well to know what the 15 means. but I can tell you that basically it's a representation of, and it could even be in black and white here, the amount of shading in a particular pixel. Okay, so it's reduced to pixels. Okay, so how do we put it actually back together to show an image? I think that's kind of a fun idea. And before doing that, let's split it into X and Y, and here's why. This first row, as you can see, it doesn't belong with the others. This is actually what the pixels combine to make up. The number 6, the number 5, the number 7. That's what we're trying to predict. The input here is all these other columns, all the other pixels, and we're going to use them to predict what the number is. Okay, so that's our Y value. Okay, so we're going to split data into X and Y here. So Y is the first column. Okay, so it's df.code with me, df.iloc, all rows, just the first column, which is the 0th index. And then X equals df.iloc, all rows. Now we're starting with the first column and going all the way up until the end, so that's the proper slicing. Let's go ahead and match that for Y test and X test, okay? You should be able to do that on your own. Go ahead and do that. So what I want you to do is get X test and Y test using index location. I'm just going to copy and paste and make the changes. You can type it in. Either way is fine. And so where are the changes and how do I know how to make the changes? Well, it's not df, right? We put in df underscore test. So that's what we use. And you don't want to like call it the same thing because then you're rewriting X and Y. And you only have one X and Y. So let's actually call it Y test and X test. Okay. So press Shift Enter after you get your Y test and X test ready. And now what you want to do is, let's just look at the shape, x.shape. And you can see it's got 2,000 rows and 784 columns. So this is a single 784 columns, but it should be reshaped into a two-dimensional grid. So what by what? Well, the question would be, what's the square root of 784? So let me show you how to get that. X.shape bracket 1 gives you the number of columns. If we want to find out the square root, we can just go to the 1/2 power. Okay, so it's double star, that's to the power of 1/2 in this case. And so do that, you press Shift Enter and you get 28. So these are 28 by 28. Okay, that's what they are. They're 28 by 28 to get 784 pixels total. Okay, so how do we actually show them then? You know, I think we want to show them. And let's say, like, even beyond that, how can we show like a random number? But what I mean, why? I want not just like the first row, second row. Let's pick a random row. Okay, so that's done using NumPy one way. Okay. I know I've been putting in text headers and things. I'll go back and do that at the end. Let's just keep coding. So import NumPy as NP. And then to get like random, well, we want a random integer, okay? And that random integer should start with 0, meaning like it's an index, okay? It could be starting at 0, and what should it end at? Well, if it's of the rows, it should end at x.shape, which are those two values. So to get the first value, it's a tuple, you put in 0. Okay, so that will give you the 2,000. Why do I, oops, I misspelled shape. Why do I put it like this instead? Because this works for any then data set if there's more rows. Okay, you don't have to go back and, oh, but this time I did in rows equals 4,000 because I wanted to see, now I've got to change it. It's going to work. Okay, so let's run that and see if that does what we expect. It does. So we got a random row, 585, random index. Try it again. Cool, got another one, 657. You get different ones, kind of fun. It should be between 0 and 2000. What we're going to do next is show the images. Okay, right? You got to see them. So how are we going to do that? Let's start with by declaring the random index. That's going to be equal to, just run this code here. Great. Next, we're going to get what I would call the random pixels. Okay. Why do I call it random pixels? Because we're converting basically. So, okay, that gives us a row, but now we want to get all the pixels in that row. Okay. And the way we do that is, again, x.iloc, yx, because x has all the pixels. And to get just that row, okay, it's not all the rows this time, it's the random index. But importantly, comma, all columns. Okay. So again, what that does, it just selects a row. Okay. Looks a little weird if you're not used to this kind of coding, but you get used to it a little bit. Next, okay, so you can reshape it, and this is a cool thing you can do with NumPy, but this is a different type. If you want to see what type it is, you can put it in. Let's check what type is random pixels. It's a pandas series, okay? It's like a one-dimensional thing, and it actually does not reshape, unfortunately. So we need to reshape it. So here's how you do that. If you convert something to NumPy, like a NumPy array, you can just put an np underscore in front of it. So we're gonna get the np underscore random pixels. This is just a type change, okay? Equals np.array random pixels. Okay. So I'll put in comments when I think they're essential. So convert random pixels to NumPy array for reshaping. That's why. Because you can't graph it if it's one dimensional. We need it to be two dimensional, okay? But it's got to be in NumPy for that. And then I think this stuff is also unclear. Get random index between 0 and number of rows in X. Get the row. Maybe I should just call it random row. Get the row with random index. I think I'm going to change it to row because pixels makes it a little more unclear. It's always good if you can make improvements in your code while you're coding. Do it, you know. Now convert random row, right? It's going to be not pixels row. Now, if you're not used to Colab notebooks, by the way, which I'm sure very few of you, most of you probably are not used to it. You've got to go back and run the cell if you make the change, otherwise it won't work. So I need to run this cell. Now I can run this one. And finally, I want to say the random image is, and now you can reshape it. It's np random row dot reshape 28 by 28. Isn't that cool? So you can do that. Reshape allows, hey, like imagine you had 6. Okay, you could reshape it to 2 by 3 or 3 by 2, anything that's going to multiply out to give you the total. So this reshape image from 1D 784 columns to 2D 28 by 28. Cool. So what this is going to do, it's going to allow us to actually graph it. Okay. I think it's exciting to do graphs. All right, let's run it, make sure we don't get any error. Good. If you get error, don't worry. You can look at my code, or you can pause the video. You can always put it in the chat. We can look at it. And sometimes there's like little typos, or one thing was changed but something else wasn't. So you'll get better at correcting errors throughout this. Okay, there's not a whole lot that's left. So the standard grapher is actually matplotlib. So what we're going to do now is import matplotlib.pyplot as PLT, shows up as an option. Then there's something called plt.imageShow, and it's a random image. Well, I say it's a random image. That's what we want to show, right? We want to show that 2D image. And then you can just show it, really. Keep it simple. Okay, so try that. Try to run it, see what you get. Cool. You should get some number, right? That's what it looks like. And by the way, if you want to see what that number is, you can just put in Y, because it should match random index, right? And again, that's the key about trying to label things properly. When you put in random index, you know that, right, it's the index of Y. It should match. And as expected here, it does match 9. Now, what I want to do, because I want to do it again, I'm just going to put all these together, okay? I'm just going to copy and paste them all in the same cell, because this is fun, right? I want to see more than one image. And this one too. Show image. Get rid of my extra coding. I kind of like this one too. So maybe we can do print, you know, the index also. Right? Just touching up a little code here to get better flow. I'm going to eliminate where there's no code, the coding cells, by hitting those trash bins. Okay, so now I should be able to do this multiple times. I mean, yes, you could turn it into a function and do it like that as well. So I got 9 again. Hopefully it does different numbers every time. Yeah, it does. So you got 5. You know, and you can just keep doing it. 1. That looks like an 8. It is an 8, right? And by the way, something else that's nice, kind of the grid doesn't matter. If you want, you can also do plt.axis. You can actually turn it off. It makes it look a little cleaner there. 0, cool. All right, so awesome. That is how we upload the MNIST data, get it ready in terms of machine learning with the X and Y, and how to actually show those numbers.